Hello and welcome to Physics Chat. Physics Chat is a show where we talk to real-life researchers at the forefront of their research and learn more about what it's like to be a modern-day physicist. I am your host, Sergi, and I am today joined by co-hosts Fox and Nathan. You all know Fox from previous episodes, but Nathan is a new addition to the team. How are you, Nathan?
Yeah, I'm great, thanks. How are you doing?
Good, thanks. So could you tell us a bit about your research and why did you decide to join the Physics Chat team?
Yeah, sure. So I'm a first year at the University of Portsmouth, and I'm studying the large-scale structure of the universe with cosmic voids, and these are the most underdense regions of our universe. I joined Physics Chat because I thought that it would be a really great experience to meet interesting people that do lots of different areas of physics, and also a great platform to get science out to the world.
Yeah, that sounds fascinating. And I think we haven't had anyone talking about voids so far. So yeah, we'll make sure we have an episode on that. Today, however, we have Chane, who's just finishing a PhD also at the Institute of Cosmology and Gravitation in Portsmouth. So how are you, Chane?
Yeah, I'm good.
Fantastic. Yeah. So Chane comes from Thailand, which is almost on the other side of the planet. Maybe we can ask the editor to put a picture there. So I'm interested to know what is the best thing of Thailand that you can't find in the UK?
The best thing is I can say is about food, to be honest, the warm weather that I can't find in the UK. Yes. Food in particular, we have, I would say fruit would be better because it's like guava or rambutan that we cannot find in the UK.
And why did you decide to come all the way to the ICG to study your PhD?
Of course, first of all, I wanted to come to UK because of you have famous physicists in the past like Isaac Newton or like Paul Dirac. So I decided to come to UK, and then Portsmouth is before I came here, I have seen the cost of living in Portsmouth is quite cheap. So and we have a good professor and we have a very knowledgeable professor and a good institute, very nice institute of cosmology and gravitation in here in Portsmouth. So I think it's the best choice to study here.
So now I know that you've finished writing your thesis. So maybe it's a good time to ask, could you summarize all your research during these 4 years of your PhD in one sentence? How would you do that?
My research is I try to find the signature of the interaction between dark energy and dark matter in the universe.
Okay, so you've talked about two things interacting. Let's break that down. So what exactly is dark matter?
So dark matter is actually, we don't know what it actually is, but we found evidence on the galaxy rotating curve. And also we can see its effect on the what we call gravitational lensing. Dark matter have gravity. They can cause they can make the light that's passed to the dark matter bend. So, but we don't have any standard model or in particle physics yet. So yeah, it's still mystery actually.
That's a really nice explanation. Thanks for that. I guess the other question is, what is dark energy?
Dark energy, actually, we have the evidence that, okay, in 1998, the two teams in cosmology found the accelerating expansion of the universe. And this acceleration, we have to add the unknown energy, which is we call dark energy, to make the universe accelerated, which is fit with the observational evidence from dark energy is, for example, it's a supernova Taiwan A, which is supernova is actually the explosion of stars. The distant star is dimmer than it should be, so that means the universe have accelerating expansion. So and we need to add this unknown term in the theory, so to fit with the observation. So that we know that universe might contain some sort of energy that we don't know, so we call dark energy.
Amazing. So essentially we need dark matter to understand all of the extra mass that is around a galaxy. and we need dark energy to understand the full expansion of the universe. So what do we mean by these two things interacting, and how might that occur?
Well, that's I would say that's a good question, because we don't actually know if the interactions exist or not. So we try to test the interaction between these two things, because the standard model cosmology right now is explain the universe really well, but we still have some problem. Like, for example, cosmological constant problem. We still have the observations bound of the Hubble constant, which is we call it tension, because the observation of Hubble constant from cosmic microwave background and the large scale structure is mismatched. So yeah, we try to find some of theory that could solve this problem. Yeah, maybe perhaps the interaction model between dark energy and dark matter could explain this thing. So that's we try to find.
That's really interesting. What do we actually mean by dark energy interacts with dark matter?
Our model is we assume the dark energy and dark matter can exchange the energy. We don't assume they can exchange the momentum, because there will be another model. And the model of interaction we can in my case we call it linear model, because it's a combination between the term of the interaction that's proportional to dark matter, and another term is proportional to dark energy. So we combine the two terms together. So this interaction could affect the early universe and late universe as well.
And how might we observe these effects?
So in the early universe, we can see, actually, if the interaction exists, we probably can see the effect on the cosmic microwave background. But that's still not enough. We have to see more effects in something else in the late universe or local universe, like galaxy distribution as well. The chain of spectrum in the cosmic microwave background could be interaction or could be something else. We still have to investigate more and more. Yes.
Okay, so you've said that it affects the CMB and galaxy distributions, but is there a specific effect that we could observe?
Yes, because the interaction model, that means the standard dark matter density will change if we have interaction, if the interaction exists. And the dark matter density can normally affect the high of the peaks on the CMB. So if in the early universe we have an interaction between dark matter and energy, that means dark matter could be decay or more matter as usual. So we will see the chips up and down of the CMB power spectrum. That will tell us the interaction that exists or not.
So Chane, now that you are one of the world experts on interactive dark energy, dark matter, I want to ask you, what percentage do you give it to it being true? If you had to bet money, where would your money be on that? There is an interaction or not?
That's a really good question. So I can say it's possible to have interaction, but in the future, it could be, if we have some observation that the interaction could grow out, so I will lose the money, actually.
Safe choice. So that sounds all very interesting. Thank you very much for all your explanations. But let's move away from the science now for a bit. So Chane is the perfect example showing that a physicist can also be an artist. In particular, Chane is an excellent photographer and also painter. So we can put here on the screen some pictures of some of his work. Could you tell us, where do you find the inspiration to do that?
Well, if you do that, it makes you feel like you have freedom to do anything, to paint anything. You can express your feeling on the canvas, the color that you would like to show.
The paintings are really amazing. So I was just wondering how long you've actually been painting for?
Actually, I started painting when I was 16, 17, something like that. This long ago, and I thought it's okay. I saw my painting from my aunt, so when I saw that, I feel like, oh, I wanted to do this, and I started learning painting in the high school and tried. Learning how to mix the color.
Do you have a favorite artist? Someone that you really admire?
I know just only one. It's Van Gogh.
Van Gogh. Okay, we can see that from the influence in that painting. Okay.
Also Da Vinci.
Da Vinci as well. Nice.
Yes.
Thank you so much for being on Physics Chat today. It has been very, very interesting to hear how dark energy and dark matter could be connected and to understand better what's behind your artistic work. Nathan Fox, do you have some artistic inclinations?
Well, I occasionally draw my D&D characters, but my drawing skills are not very good. So I tend to use free 3D modeling tools online with modular bits of armor sets and things to create them. And sometimes I do some origami, but that's about as artistic as I get.
My art skills haven't been practiced in a while. I think I used to draw a little bit, but I haven't in a good many years. Personally, I'm more into music, which I guess counts as art.
Yeah, of course.
So,
Thank you.
Fantastic. So people, let us know in the comments what's your favorite form of art. We are very interested to hear from you. That is all we have time for on today's Physics Chat. So we hope you join us next time as we talk to some more interesting physicists. We have some awesome people lined up for you. So stay tuned. Otherwise, from everyone at Field of Bio, we hope you have a great day and goodbye.
Bye.
bye.
Bye-bye. If you do that, it makes you feel like you have freedom. You can express your feeling on the canvas.